Alrighty, hi everyone. My name is Chinmayi Balusu, and I'm going to be hosting this student research during COVID-19 workshop today. And I wanted to give a big shout out to Internnet for having me today. Thank you so much, guys. So a little bit about me to start off. Otherwise, you're going to be wondering who this random stranger is. I'm currently in my second year in college at Columbia University in New York City, though I'm actually at home in Northern California right now with the friendly sunshine. Currently studying neuroscience and medical humanities. I haven't actually formally declared my major yet, but those are sort of the two spheres that I'm inclined to at the moment. Um, you may have also heard of Simply Neuroscience, maybe come across it on social media, but I'm the founder and CEO of this nonprofit organization that's called Simply Neuroscience, and it's based around interdisciplinary neuroscience through a framework of education, outreach, and awareness. And a lot of my experiences and background are tied into neuroscience and the natural sciences in general, I would say. In the past, I was involved with research focusing on biomedicine and neurodegenerative diseases. And currently, I'm involved in research at Columbia and Stanford Medicine, where I'm working on cognitive neuroscience related research and traumatic brain injury studies, respectively. Um, Outside of that, I guess more science. I'm really passionate about sharing science outreach with younger students and many of their communities as well, just addressing the importance of breaking down science in an easily digestible manner for folks anywhere, basically. Some of my hobbies include gardening. I practice Taekwondo. I really enjoy watching old older movies and such, and happy to chat about any questions after this presentation as well. I'll be dropping my social media contact info and such. And like was just dropped in the chat right now, you can also drop questions during the chat, and we will be having 30-minute long Q&A just for questions specifically, so we can also chat about lots of questions there. So hold on to those questions until about half an hour or so, or you can drop them in the chat as we go. And now let's get started. So voila, this workshop's name is obviously student research during the time of a pandemic, right? But let's first backtrack a little bit and talk about what getting involved in research really entails. Because as high school students, I'm assuming most of you are in high school, you've probably heard, the importance of getting involved in research internships and such tossed around quite a bit. And some of us, first time we're hearing it, we're like, okay, I get that, research maybe is like you go do some little bit of digging on Google or something like that, or maybe you have prior exposure to scientific research. You're like, I see what it is. But then the question pops up, what does a student do in research? What exactly do you do when you're getting involved in research in high school? So most of the time, research involves some form of original contributions or original learning that takes place outside of the classroom for the most part. So if you are associated with a research laboratory, for instance, and this could be at a university or a private institution, or a research program or a summer research camp or anything like these, you're most likely going to be helping out in a hands-on manner. You're going to be gaining in-depth knowledge in a certain particular area, and you're probably going to be developing an independent project, exploring some sort of question that you have on your own, or you might be assisting and adding on to an existing question, um, such as, will green M&Ms really make my tongue turn permanently green? Maybe that's an existing question out there, and you might go contribute to that sort of research form. Or as an offshoot of that, one day you might have a question pop up, as in, what if you had purple M&Ms? Would it stain your tongue just as much as eating green M&Ms would? So that's kind of different routes of exactly getting involved in research means. And overall, it is really challenging, especially during high school, because a lot of these different research initiatives and current opportunities and such really ask for some sort of in-depth knowledge, extensive knowledge in a particular field. And I mentioned that I have more experience in the neurosciences side and the biology side, so I may be more gearing towards some examples in that line, but please bear with me and translate to your recording field of interest. So as a challenging case, let's say, when it comes to neurodegeneration, when we're looking at diseases such as Alzheimer's, Parkinson's, Huntington's, a lot of these diseases have different interactions on the protein level, on the molecular level, biochemical level, that can present these, bigger disorders that we see when patients exhibit these symptoms in real life. But to understand how exactly it translates to know the overall person level, what's really contributing to these symptoms, you have to dive down into the really, really minute details as well. And all these, bunch of different proteins and such like that, all these minute interactions can require quite a bit of educational background. Advanced courses that you might take in, in your upperclassmen years of college or something. So, you're sitting there wondering, how do I really do this as a high school student? And to be honest, that intimidated me a lot too, a couple years back. But why it's really important to still get involved, and learn along the way is that you can really gain insight into the academic world. How exactly, what is going on behind the scenes of cutting edge research. And potentially you can even contribute to some groundbreaking outcomes, even if it's on, you don't have to cure Alzheimer's disease, right? It's definitely an endeavor that's been underway for a long time. However, you can still contribute a very meaningful, smaller scale, significant result that maybe can change some thoughts about current notions of what directions are. Also, friendly reminder to keep yourselves on mute. Sometimes you can accidentally unmute yourself. I do that too. So that's a little bit about research, right? And that's still a very vague picture. So while we go through, I'm going to try to bring in some of my own personal experiences of research projects I've been involved in to try to paint a better picture for you. So let's talk about first, okay, maybe you think that research opportunity idea seemed pretty cool. And now you're thinking, okay, how do I really know what form of research that I want to get involved in? What are the types of questions and line of thinking that I want to explore? So finding that research interest of yours, a great way to do so is through school. Oftentimes in biology class, for instance, outside of learning from your textbook, or even in your textbook, you might see these little action blurbs on the side that connect things to the real world. For instance, if you're learning about XYZ protein, and this is implicated in Alzheimer's disease, that's a real world connection right there beyond that little minute biology fact you have there. Especially in courses such as AP Environmental Science, for instance, one of my favorite courses in high school. There are lots of issues that have been addressed and that solutions are being created for through scientific research. So for instance, if you're looking at, let's see, deforestation, for example, there's probably a lot of background research going on about the effects of deforestation on animal habitats, human-animal interactions, maybe especially in indigenous communities who are being affected by deforestation. All these courses can really tie into those real-world concepts to think about. Especially science news too, sometimes you might have an assignment related to reading a science news article, summarizing it, something along those lines, but definitely keeping up with these real world issues can spark that kind of discovery of what you really want to look into. So social media is really big these days, especially with everything being online and newsletters too. Some of my favorite ones are Scientific American. The New York Times science section is pretty great. A lot of different newsletters out there to really check out. Nat Geo is amazing too. They don't just do, earth science related stuff. There's a lot of things going on, Smithsonian, these different places. And on social media too, there are plenty of Instagram science accounts out there that I've seen, and Twitter too. Really great ways to get bite-sized pieces of info showing up on your feed, daily basis, weekly basis, whatever you're inclined to. So that's a little bit of, thinking about what are some real world issues out there that I'm interested in exploring. It may be, working to raise awareness about eating disorders, may be related to, the global food crisis. How can you contribute to that on a minute level? So it can be pretty big, it can be pretty large scale thoughts, just ideas, things that you're interested in overall. So now we're gonna go from that very wide level to sort of shifting it into a smaller scale. Now, most research will probably, if you're looking for a mentor, may take place through a university or an institution or some sort of formal program. And I'm going to touch upon this later. But what you can also do is that you can look through current research that's going on specifically through the eyes of a faculty member at a university. So faculty member, usually meaning a professor, someone who has tenure, who's paid to do research at a university oftentimes. So just throwing off the top of my head, I'm biased, but Columbia Neuroscience, for instance, has a wonderful institute that's called the Zuckerman Institute, cutting edge neuroscience research there. And I think it's incredibly fascinating to sometimes pull up the Zuckerman Institute webpage. You can go to the people, about us, faculty, some sort of link on the websites, And you can scroll through the different laboratories' websites to see what research is going on in each little cluster. And that kind of gives you an idea of what types of big questions do research investigators these days have. Now, are you going to develop a question that's on the same scale as, a very large principal investigator at a university? Maybe not likely for your first question, right? They've done a lot of work in their field, they have a lot of experience, but by taking in the world around you and formulating questions that, maybe have sparked from your science assignment, have sparked from looking through these different news articles, websites, you can look at a smaller scale question that maybe you have more feasibility to do. As an example, wow, it's been quite a few years. But my freshman year project in high school was looking at correlations between factors of depression in individuals. Because when we think of depression factors, risk factors, we might think of alcoholism, for instance, any history with
No,
drug
I want
abuse.
noodles.
Oh, it's wonderful that you want noodles, my friend. You might want to mute yourself though. So you might think of alcoholism, drug abuse, maybe family history, um, any factors such as these. But I was wondering, is there really some hidden underlying factors that are somehow linked with these more well-known factors that could contribute to some underlying developments? And so there were some interesting results that came out of there. Found that, for instance, familial history definitely played in a large part. Eating habits, even during childhood, even if they've shifted a little bit as you've grown older, but eating habits from when you're younger can definitely play a part as well. So many different factors. So how did that really spark? It was from looking at prevalence of depression within my own community, young students who were, exhibiting symptoms with depression and receiving diagnoses, especially during middle school. Kind of a period where there were a lot of changes going on. So that was something that honestly sparked from looking at a local level, kind of what was I seeing in my community? What were the people around me going through? So, it doesn't have to be, I didn't set out to definitely solve like global poverty in one day, but it's on a minute level, just without curiosity to try to see what's really happening in my life and, take it and make it into a concrete question that you can answer. Now, whoops, I should probably move there we go. So types of research opportunities. I alluded to this before. You can always have independent exploration, especially with a lot of science fairs. You can look on an independent project on your own. If you have like a little bit of a background from maybe a stats class or a math class, you can do a little bit of math analysis as well on your own. And it doesn't have to be too complex. Now, this can be oftentimes difficult if you're harnessing the power of some more complex fields, such as neuroscience, for instance. It can be a little bit difficult to approach an independent project on your own without some form of guidance or support from a mentor in advance. However, this is possible. Summer research programs are a really, really, really great way to slide into an understanding of research, get an exposure, while in a structured format where you are receiving constant support. One big issue with the next point, which is academic year internships, where maybe you're throwing yourself into something that's heads on, is that you're not going to have the structure of the formal, scientific process. This week I'm going to explore what's going on. This week I'm going to set a hypothesis, test, review, maybe test again, and then present. Real world research does not always work that way. So summer research programs are a little bit, they're sheltered in a way, in a good way, because if it's your introductory experience, then you can make sure that you're not completely intimidated, blown out of the park by how scary research is, because it's not. So really, maybe 3 weeks, 4 weeks over the summer, even if you just type up summer research programs for high school students, bunch come up in Google. So Google's your best friend. Highly recommend checking these out. I think a number have shifted virtually due to COVID-19. Some have been canceled, unfortunately, but keep on the lookout for those if you're looking for your first experience, and also not much time during the regular school year. Academic year internships are a little bit difficult to get, especially nowadays, because from the undergrad perspective as well, I see that a lot of senior researchers, principal investigators, funding issues are coming up. How do you really conduct research in the virtual landscape, especially if you are more of a wet lab focused group? So the ability to take on high schoolers, I think, as research assistants and interns has decreased quite a bit. So I just wanted to put that out there, as a disclaimer. Don't be, afraid, feel like rejected if someone is not able to take you, because the world is kind of chaotic right now. So it's probably not your fault. Shadowing is often also a great way. If someone says, they don't have time to take on a research assistant, they can't assist you with completely investing time on you for an independent project of your own, but you want to learn more about their work, especially if they're sort of a physician scientist, maybe with an MD, PhD degree. Shadowing is a really great way to understand what exactly does their career and responsibilities consist of. However, we'll also acknowledge here that there are a lot of restrictions related to clinical regulations for a lot of physicians, especially. However, if you're looking at a faculty member, a professor who's more on the pure academia side, it's probably going to be a lot more easier to just hang out with them for a day, learn about what kind of meetings they're attending, and such like that. Camps tie into a little bit with the summer research programs. Again, these could be 3-4 week programs, maybe working in groups with students, and this also highly recommend Google. Now, I put wet lab, clinical, and dry lab / computational down here as 3 forms of research settings that you're most likely going to encounter. Wet lab right now, it's mostly out of the picture because of COVID-19. Wet lab, you may be in an actual laboratory space. You might be working at a bench, for instance, doing a lot of hands-on techniques, running a PCR, for instance, doing a lot of pipetting. The clinical space is also highly restricted at the moment. Clinical, you're probably interacting with more patients. This is very rare to get involved in the high school setting in clinical studies. Even in college, it's pretty difficult to get involved in because there's so many regulations. But this is more, on the hospital level, healthcare level. You're gathering information from actual live human patients that come in. A lot of confidentiality involved too. I want to backtrack a little bit to wet lab. You may be working with a lot of tissue specimens, right? So if anyone says they're working with yeast cells, mice, for instance, mice tissue, flies, you're most likely going to be looking at a wet lab setting. Clinical setting is more usually human participants. Now, the dry lab setting, most people commonly associate this with computational related work, maybe a lot of coding, technicality aspects. I will say not necessarily all the time though, because this dry lab sphere can also include a number of human participant studies that are not in the clinical setting. So these may be regular healthy volunteers coming in to complete a task or a study. Maybe they're asked to respond to a stimulus that pops up on a screen or press a button. A lot of cognitive neuro and cognitive psychology studies consist of this. So think of it as, without the chemicals, maybe some statistical analyses and some human participants potentially. Now, the pure computational aspect may be that you're not working with anyone, not working with specimens, but pure data. So a lot of databases, pulling data points together, lots of statistical analyses, wonderful visualizations that I always wonder about. Amazing. So there's truly, different spheres for everyone. I will say that I hopped from dry lab to wet lab to a little bit of a dry and wet, and now I'm doing a little bit of clinical. So I will say, it is completely possible to gain exposure in all these different spheres as well. Even if you consider yourself, pure CS kid, and you're like, it seems like dry lab is the best option for me. There's always ways to really pick up new skills. Even if you don't consider yourself, adept at using a pipette, for instance, in a wet lab, there's always ways to sort of shift and explore. And it's in fact highly encouraged to shift and explore and not really settle yourself into a niche too much. So now the big question, finding an internship and a mentor. Especially difficult these days, right? It's why we're here. Research these days is highly difficult because summer programs have been canceled. We're in the virtual modality, things are odd. So really easy things to knock out very quick. Google, I mentioned looking for summer research programs, just type that in. There's a lot of databases that come up online too. Take advantage of Google, really pulls a lot of things together for you. Another thing to really easy is to ask a teacher. Sometimes teachers have wonderful resources sitting in the back of their minds and wonderful connections that we don't necessarily, utilize to our finest, extent. Some teachers, may have friends at local universities or colleagues who have connections with local, university research programs or sometimes internships that they can refer you to. So if you are a science student, if you have a biochem, physics, psychology, environmental science class right now, you can always ask your teacher to help you point yourself in the right direction to go search for these opportunities. Now we get to the fun part. This is going to be more in depth. Cold contacting, networking and getting in touch with grad students and postdocs, right? These all kind of tie together a little bit. Now, cold contacting is probably at the key, at the heart of securing an internship that you have no connection to whatsoever. You just stumbled across it and you're interested. And if you're the type of person that is looking for a opportunity outside of a formal summer research program, that's perfectly fine too and highly encouraged as well. And I will say that the biggest misconception that a lot of students have, and this is something that I definitely, used to believe as well, is that you must only work with the principal investigator of a research laboratory in order to get involved in research. Well, I will say that is a great lie, and oftentimes maybe impractical too, especially now. So to clarify a little bit, principal investigator, who is this person? So principal, meaning, primary first, the lead, is usually the lead researcher for a laboratory. Let's say, you come across a laboratory website, they're called the Smith Lab. You'll oftentimes find that the Smith part of the lab is named after the principal investigator. Sometimes, not all the time. You may find something like the Scan Lab, which has no Dr. Scan there, but Dr. Smith is probably the principal investigator of the lab. So they are oftentimes, receiving funding from the university. They lead all of the postdoctoral researchers, all the PhD candidates, undergrad research assistants, everything for that specific research group, basically. Now, principal investigators, as you can probably imagine, dealing with all that, leading that lab, are extremely busy. So oftentimes, they're probably not going to be able to take on a student like yourself as a high school student because it's a lot of time to invest, maybe. Sometimes if it's a smaller lab especially, you may be able to work with them more closely. Oftentimes with larger labs, if you have, oh, please mute yourself, guys. If you have a larger lab with about 30 members at times, then it may be extremely difficult to find a research mentor in the PI themselves because they're just honestly very busy individuals, however amazing they may be. So who are other individuals in the lab then that can help you out? There is, oftentimes the postdoctoral researchers. So postdoc, so the doc part is basically the PhD, the doctoral degree. So postdoctoral researchers are often those who have received their PhD degree, and they're oftentimes called doctor now, like Dr. Watson or something like that. And they're oftentimes conducting their own independent research under the guidance of the greater labs framework, basically. And you'll see that the postdocs, the PI of the lab, the graduate students, everyone is working around some cluster of common topics, right? If the PI is focusing on, their expertise is on neurobiology, you're likely not going to find a postdoc in the lab who is working on like neuroeconomics unless there's a very strong tie to what the PI is focusing on. This is for, grant reasons as well as practicality reasons in the scope of research overall. So postdoctoral researchers oftentimes have the means to take on various research assistants. They have a PhD themselves, definitely experts in their field. Other individuals in the lab are graduate students. So graduate students can mean master's students as well as PhD students or PhD candidates. So people who are pursuing their master's and people who are pursuing their PhD program. These individuals, often have their bachelor's degrees already, and there are students themselves, but they also have prior experience in the field. So they're oftentimes, I think, very, very valuable mentors because they're closer to your age, most likely. And it's more of like a near peer, not quite near, but more of a closer gap when it comes to educational atmosphere, experiences that are more relevant to you at the moment than perhaps an older professional would have. So something to keep in mind as well. When I was in high school, no one really told me about the value of having graduate students and postdoctoral researchers as mentors. And it was always kind of the perception that, oh, you had to work with the PI of the lab. That's such a misconception. Honestly, any member of that lab can probably mentor you in a very, very valuable way. Lab managers, postdocs, PhD students, master students, and the PI, they're all probably very, very valuable mentors. However, what is, the feasibility of having them actually mentor you? How do you really secure that mentorship? Oh, please mute yourself, my friend. So cold contacting is going to help you out in that case. Now, cold contacting means that you probably have no previous contact with that person and you have never met them before. Maybe you're familiar with their research, The best way to go about doing so, is probably looking through their website, looking what they've worked on previously, skimming some of their past papers, seeing if any of their interesting titles seem a little bit exciting about what you're looking to do. There is nothing more embarrassing than if you approach someone saying, "Oh, I love your work in neurobiology," but then they respond back to you saying, "Oh, yes, I did my PhD in neurobiology. But if you look at my recent trail of papers, I'm more focused on the maybe biochemical, neurochemical side a little bit more." So it's always important to think about what exactly they are working on at the moment, not just their past degree or something like that. That comes through getting the full background picture of what they are currently working on through conducting a little bit of research into their own research. It's kind of odd to think about, but you want to get the full picture, what they're working on. So let's say Dr. Smith. Let's go back. Oh, Dr. Watson. Dr. Watson was the postdoc in the lab. So I'm going to go look at Dr. Watson's webpage if they have an independent one, or go look at the Smith lab in which Dr. Watson works. And let's say, they have a interest in, what should we do? Brain injury. My personal interests are in brain injury too. That's very cool. So I'm going to try to look for some specifics about what exactly they are doing in brain injury. Is it that they're focusing on concussion, for instance? Are they focusing on the effects of brain injury on children, in older adults, geriatrics, things like that? Because brain injury as itself is a very vast field. So you want to understand, and you want to showcase that you understand what niche that they are working in, because it shows that you've put time into understanding what they are working on, and that they could be a valuable mentor for you because you're interested in their niche. A lot of back and forth arrows there, you might have noticed. But cold contacting email, how it's basically going to go is that you're going to write like, "Dear Watson," you're going to introduce yourself. "Hello, my name is so-and-so, my name is Chinmayi, and I'm a high school student at XYZ. My current interests in science are brain injury, XYZ," and you're going to tell them, "I am greatly interested in getting involved in research or gaining exposure to research because of my previous yada, yada, yada." Now, what goes in that yada, yada, yada is your story of why exactly you got involved in research. Now, never tell a researcher that you want to get involved in research because your parents said so, or that your friends said so, or that it's going to help you get into college. Nothing of those sorts. Do not do it ever, please. Such a red flag, and no one will get back to you reasonably. You want to show why exactly did that interest in research spark for you. Let's say, maybe your friend would tell you like, "Hey, you should do research because it's good for college." But you're going to need to have some personal motivation to actually get involved and actually produce and work on meaningful content, right? So, and why is getting involved in this hands-on manner going to further your interests in brain injury? Why is it going to further your interests in the long term as well? Are you interested in pursuing a PhD or an MD or an MD PhD or a master's degree or working in industry? It's always great to also detail your future plans. Now, you also want to tell them, so we had the intro, I'm in high school, this is what I'm curious about, I'm really interested in research because of XYZ, and then you drop the connection there, as in, I am reaching out to you because I have read about your work with brain injury work and pediatrics, and I personally think that is very interesting and a field that I want to explore in the future. Therefore, I'm looking for the support of a mentor, and I'm looking for a research opportunity, for instance, where I can really explore this field outside of my high school classroom and gain more real world experience. So that's a big jumble, but it's kind of jot down what you think is most applicable from there and what you think speaks to you. And then you want to say, you want to be polite, right? You want to say, you want to really detail, why their specific work. The big issue at the end of the day is you don't want that individual. Here's the thing. If you have that email draft and you could take out Dr. Watson's name there and put Dr. Fred's name in there, and you could send it and it would work for both of them, then that's not specific enough to them. So, for Dr. Watson, it may be, "I really liked XYZ study that you had in brain injury and pediatrics." And Dr. Fred, it could be something specific like, "Oh, your analyses of types of patient controls and concussion," or something like that. Was really interesting to me. Do you see that? The specific level, you want it to be different for every single person that you cold contact. You don't want it to be an umbrella overall email. because that you can just copy paste names and put and send, because people usually know that if you are sending out a very general cold contacting email, then you probably are sending that email out to a lot of folks as well. Now, touch upon this, wrapping up this draft email and then moving on a little bit, but you want to be, considerate, thankful for your time, all of that. And oftentimes, tip, send over a one-page resume with basic experiences, any classes you've taken in school, things like that. There are lots of great templates online in Google. We're also running out of time, I just realized. So I'm gonna try to wrap up quickly so we can do more questions, but you can search up cold contacting templates. You can search up resume templates, all of this online. And we shall, it'll come back to me. Let's see, networking. I'm gonna actually shy away a little bit from this because we're running out of time, but oftentimes this may be more applicable to college folks, especially people who use LinkedIn, for instance. It's a great way to send a message to a researcher who's on LinkedIn, for instance, saying, hi, I'm so-and-so, I'm a high school student, I'm really interested in work in neuroscience, and I think that it'd be great to connect with you and learn more about your research work. And then you say, thank you, and I would like to connect with you on LinkedIn. And that can get a conversation started. However, I will acknowledge that a lot of researchers may be not so frequently active on LinkedIn. It's sort of science and networking and the sciences is a whole nother discussion for a whole nother day. So it's just something to keep in mind. Emails are often the most effective way to go about doing so. And how do you exactly, find people to email? Look at local universities. And by local, it could even be 200 miles away or on the other side of the United States or another country as well during this time, because we're all virtually connected. But you want to search up, for instance, Alzheimer's disease research at the University of Cambridge, for instance, and go see if you can find any labs there. So you want to narrow it down from the scope of a university to a lab and then to a person. And Google is a big help there as well. Now, sharing about your research. Science fairs are a very big way. These are pretty self-explanatory. I highly recommend this website called Science Buddies. I think it's sciencebuddies.com or .org. Excuse me. But they provide a great background for how to get started with science fairs, especially if you want to do an independent project as well for a science fair. They have a perfect, framework for you. You can, let's say, you manage to secure a mentor, you're starting to work on some things. You can start maybe writing a blog about your findings or what are your experiences in research. I also like keeping a little journal because sometimes there are some, light bulb moments where you're like, science is cool. That's very basic. But those light bulb moments, it's always great to jot down. This is skipping ahead quite a bit, but there's always opportunities to publish in youth science journals. Google's also a great place to search, and mentors may be able to recommend other publications for you as well. And you can always present to your classmates in high school. It's something that we don't think about too much, but it's always great to share our work with our classmates. Youth science journals. I believe there's one called Young Scientists Journal, Columbia Junior Science Journal. There's the Journal of, can't remember if it's Young or Emerging Investigators, but that might be for college. I think Columbia Junior Science Journal is pretty big among high schooler folks. Totally not biased. But those are sort of two I can think of off the top of my head. I think there's one called the Scientific Teen, I want to say. I'm not quite sure. Please fact check that. And oftentimes, if you're working with a mentor, they may include your contributions of the project into a wider paper and maybe list you as an author as well, because there may be multiple authors on these papers, and it may go publish in a higher impact journal, especially with the backing of a mentor, the PI of the lab as well. So some students, if it's more of an independent project on their own scale, they just want they're at full, start to finish and doesn't really fit into a larger subset of the work in a lab, then it might be wise to publish in a youth science journal. Likelihood is also more, high, but it's always something to consider. This whole concept of sharing your research on a more formal publication level definitely depends from opportunity to opportunity, mentor to mentor. The support of a mentor can definitely help greatly, I would say. Now, let's say cold contacting, we skipped a little bit on the last side, probably should have switched these too, but let's say, got back from cold contacting, someone actually responded back to you and they were like, let's hop on a call. You hop on that call, you show your dedication as much as possible, right? You say, I can dedicate this much time a week. I'm on top of my school homework. I'm on top of my extracurriculars, and this is going to be a great opportunity for me. And this is why, like, I'm the perfect person. Talk about your skills and everything. And let's say you secure that internship. Wonderful, congrats. Now, you want to be willing to invest time that you said you would, and that you should, because research is not something that, just you can finish a project up in a week and then you're published and you're at ISEF. It does not work that way. And it takes so much time, and it takes a lot of failure as well. It's kind of the cliche thing everyone says in science, but it's really not cliche because it's such a big part. So you want to be humble and acknowledge your failure. Sometimes your different procedures in a wet lab are going to go completely awry. You're not going to get significant results at all. Or your data analyses, it's completely off. Your p-value's like over, off the roof. It's crazy. And you can acknowledge those failures in your papers as well. Scientists, in fact, are a little bit suspicious, I think, when you see no sort of discussion of error or limitations or anything in a paper. That's sort of a red flag, because there's always limitations and errors in science. Now, you want to know your work inside and out. You want to be detailed. Even if some things are very, you might be like, oh my gosh, I'm probably not going to learn that until graduate school. Like this protein over here, I don't know what it does. You want to try to still get your hands on and wrap your mind around as much as you can of what this XYZ concept or what this XYZ protein does. So always ask questions. There's no such thing as a stupid question when you're talking to your mentor. Now, I will say, we want to be considerate of their time as well. So always try to, get a little bit, see if you can get your grasp on it a little bit. So many wonderful resources on YouTube, for instance, explaining concepts, and then ask your mentor about it if you're still confused. And I'm sure they would be happy to explain. Learn about others' work and take time to explore a literature trail. What I mean by this is look at previous examples in the field, look at previous sample works, things like that, previous science fair projects, things like this, and explore kind of what has been going on in that field, for instance. What I mean by following a literature trail is that you want to backtrack through a paper. So let's say you open up a paper, you go to the end and there's like a bibliography references section with a bunch of citations in there. Go look through those papers and see if there's anything interesting that's relevant to your topic, and then follow that chain, jumping from paper to paper to paper, depending on what's relevant. Also, learn how to skim abstracts, which is the first part of the paper that you'll probably see at the top, quick summary of what it involves. You want to learn how to skim those pretty quickly, so you'll probably be reading a lot of them. That is a whole discussion for another day as well. Go to good old Google. There are lots of resources on how to break down, honestly, any of these steps. This is just a very wide umbrella covering, I would say. Cool, that was a very, very fast run through. And I think you can probably see that there are so many different steps when it comes to actually identifying your interests, actually knowing about how to reach out and how to make the most of it. We touched more on the identifying and reaching out aspect, more so than, okay, I have found an opportunity. How do I take advantage of it? That's honestly, these honestly are kind of full day long workshops that actually people host. So this is in no way comprehensive in any manner. I will say that if you have, any like questions related to neuroscience specifically or getting involved in neuroscience research, that I can help out, feel free to, you can find me on LinkedIn. You can find me on Instagram and Twitter with these handles. And I will also say that this email address that I'm going to type in the chat, this is called advice@simplyneuroscience.org. So I mentioned that I lead Simply Neuroscience, which is a nonprofit, and we are, all of our resources are completely free and for students like yourselves. So this advice email is actually an advice email hotline. So if you have a question about securing a neuroscience research internship or anything in that, means, you're lost on where to exactly, I don't know what exactly I'm interested in, that's fine too. You can reach out to this email. And we have, a team of volunteers, high school undergrads, and even some of our advisory board members who would love to hop in and answer your questions. So we'll take a shot at answering, a lot of questions right now. Let you guys take a screenshot if you need to of this slide. You can also, if you're lost, just feel free to, careful. I think you might be writing on the screen share. That's odd. Zoom is always odd. But honestly, search up my first and last name and you should be able to find me, or Simply Neuroscience. Now with that, I can see faces again. How wonderful. Should we go back through the questions?
Yeah, sure. Okay, so I can just read out some things from the chat. Um, so one of the first ones is if you could start over, what would you change about your youth science communicator journey, and would you start in a different way?
Yeah. Well, I think like a little bit of the next question as well ties in really well too. How do you start as a youth science communicator? Frankly, I don't think you don't. um, I think science communication, as the field and discipline that it is, really, is something that a lot of older folks kind of get involved in through their research or their existing career. So if someone has a PhD, for instance, and they're involved in research, science communication really entails taking that form of, their expertise, taking their findings, and trying to translate it to the public in an effective way. So a lot of times these individuals are working with outreach programs at universities, hosting, it's kind of Saturday science events for students, for instance, or workshops on a local level. Anyone in New York City, like BioBus, um, those kind of programs and such are really based around science communication and outreach. Now, youth science communication is really odd because I obviously do not have a PhD. I don't even have my bachelor's degree at the moment, working towards it. So, what really my focus is, and I've honestly struggled with like the concept of actually calling myself a youth science communicator. So, story for another day as well. But what I've realized is that I'm involved in research at the moment. I've conducted a little bit of independent work myself, and I'm contributing to others' work as well. And at the end of the day, I'm in no way an expert in this research. However, I do have a passion for neuroscience. I have experience with neuroscience outreach efforts and trying to bridge the early neuroscience gap, especially getting more students interested and involved and equipped with resources. And that's really what kind of drives me. I think honestly, founding Simply Neuroscience was kind of the way I got into being some sort of youth science communicator. Because I really started, thinking about, okay, yeah, I'm a neuroscience kid in the classroom and in the lab, but I also want to be a youth leader in my community and help students understand, what exactly neuroscience can bring to their lives, what it can add to their own careers and such. And, we didn't touch upon that aspect too much in this workshop, but that's sort of how I stumbled across it, to be honest. I had no intention of waking up one day and saying, today is the day to become a science communicator. In no way. It was something that definitely grew. And I think a lot of my research experiences with kind of thinking about how does this apply outside of the laboratory as well to the big world out there was a driving force.
Okay, another question is, how do you approach PIs? I'm assuming that's principal investigator, whose research you're interested in, but you might not have a complete understanding of the work that they do.
That's honestly perfectly okay. Um, I'm assuming, this is some probably highly technical aspect work, especially when you get into pharmacology or forms of neuroimaging, for instance, if you're thinking of like MRI, CT, PET scanning, for instance, there's a lot of technicality with them. So I think what's important to understand is that, let's say you're scheduling an interview with this person. You want to be able to understand enough of their work to see kind of what their motivation is, right? So let's say they're using an MRI scanner for XYZ. There's so many technicalities with that. But what are they specifically using it to investigate? Like, what is the function? What kind of aspect of human behavior, for instance, are they trying to understand? Let's say they're using an MRI to study attention and memory interactions. So, the attention and memory part is what they're focusing on. Now, MRI is so complicated. And what I will recommend though is that there are a number of the little crash course videos on YouTube beyond the crash course channel itself too. So like, how does an MRI work? I would honestly just recommend searching it up in YouTube and trying to get a base understanding of what exactly that machine entails. Like we all know it's a scanner, yes, but maybe what does a patient who goes in to get an MRI experience? Why is it called magnetic resonance imaging? So there's some sort of magnet in there, So what does that magnet try to do? Why is it there? You want to understand, get a very basic understanding. And a lot of PIs especially will understand that you're in high school. A lot of, college folks and even graduate students too, no one's an expert. So it's perfectly okay to know to if they ask you a specific question, you can say, I'm still trying to learn about like what MRI consists of. However, I think that it was a very interesting way to use MRI to study attention and memory, because they could approach it from a regular, um, like a regular study or a task, like I mentioned before. You sit on a computer, give a participant a computer task to press buttons with, respond that way. Why are they using MRI? So if you're confused about the the how of what someone's going about doing, the methodology is what it's called, then try to understand the why. Backtrack a little bit. Why can MRI present a different perspective on attention and memory than using a regular computer task can? So think about it that way too. And I think that, if you spend a little bit of time trying to understand their approach to the methodology, even if you don't understand the specifics of methodology, that still shows that you're interested in trying to understand what the scope of knowledge that you currently have.
Okay, uh, how would you say is the best way to get an opportunity to shadow someone? What about shadowing virtually?
Yeah, I would say if you're more interested in the medical side, maybe even MD, PhD, there are a number of, oh, excuse me, virtual shadowing opportunities out there at the moment. I'm so bad with finding names at times, but I know Brain Turns was one with the Lenox Hill Neurosurgery Program. Anyone participate in Brain Turns? Um, so Brain Turns is a really great way to get an idea of virtual shadowing, for instance. There's also a bit of a research emphasis there too. That's kind of, I think there's actually a program that's called Virtual Shadowing, the literal name, on YouTube. So highly check that out as well. I think Dr. Ryan Gray as well from like pre-med, something pre-med, mapped maybe, but also some virtual shadowing experiences there. Shadowing virtually someone, like I mentioned, if they're a medical professional right now is going to be difficult because of all the technicalities, especially if you're a minor under 18. If if it's a postdoc or a PI or someone and you're like, I want to learn about a day in your life looks like, then you can maybe hop on some lab meeting calls with them. Of course, if it's like a more of an individual, they're working with another mentee, you can't sit in on those calls, right? Because it might be confidential. However, if they are attending a talk one day, for instance, a lot of seminars usually happen where faculty attend one another's um, talks, basically, or they have a full lab meeting there. All the members of the lab are meeting that day for a catch-up meeting, things like that you might be able to sit in on. So if you are looking to shadow a researcher, I would say you have that cold contacting email template, that was more geared towards finding an opportunity in research. But I would say I'm really curious to get a more hands-on look at what a career in academia looks like, what a career as a faculty member looks like. And I was interested, um, I'm reaching out to see if I could potentially shadow you for a day, maybe join you in some of your duties and seeing, what exactly your life as a researcher looks like. Um, there are also, I'm pretty sure there are drafts out there, like template drafts out there on Google, mostly for any type of email, I would say.
Okay, are there any specific summer research programs that you would recommend?
Yeah, let's see. I do feel a little bit removed from high school summer programs, I will say. Um, I know there's one pretty famous one that's called, I think, RSI, Research Science Institute, but that is like highly, highly technical, oftentimes for students who are a little bit more advanced. Um, I will also say that a lot of universities have their own form of summer programs and camps. Oftentimes, if you go to a university page and you see that there's a tab called Education, and you scroll down a little bit, sometimes they have programs for high school students listed there. So they might be an interesting way to explore. I know for sure that Columbia has a summer program. I think a lot of private universities also have some form of summer programs, or you can take classes. Also, not exactly research, but it can be an interesting way to get a look into research. Um, I know there's quite a few in New York City. I think Brainiac, brain, not with the NIA though. I think it's Brainy with a Y. But Brainiac, BioBus, um, programs like that, like outreach programs, are really great. Um, Oftentimes, if you have a pretty solid, strong university, like Zuckerman Institute at Columbia has quite a few neuro research programs for high schoolers. I believe Stanford also has quite a few, so look into Stanford as well. Um, a lot of the private universities big bet on that they probably have funding and support for specific summer research programs, or at least camps that are about 3-4 weeks long. Also, a grain of salt that a lot of programs are unfortunately being canceled or postponed for the coming summer. So don't be discouraged. I think everyone at this point, understands that some things are not possible to go around. So there may be alternate ways to, look into those kind of opportunities. Like I mentioned, shadowing, for instance. The Brain Turns program, I think, they're trying to make it happen in the summers now. So things like that are really great to engage with through your home. So nice things, a way to get some exposure. And also, if you're looking for, if your summer research program, let's say, got canceled, or the one that you were interested in got canceled, and you're like, oh man, I really wanted to get some experience in research before I head off to college, I will say that the summer after you're graduating from high school and you're matriculating into college is also a pretty strong summer, if that's something you want to explore at that point. I know many people use it to travel these days, but alas, we are stuck at home. So a great summer to also enrich yourself if that's sort of what you're interested in and not burnt out from senior year. Something to consider as well. I will say that there are, also a multitude of opportunities to get involved in research in college. So, if you're interested, but some reason, circumstances come up because of the pandemic or personal reasons, financial reasons as well, it's not possible, do not feel dismayed. There are plenty of opportunities during college, especially. I would say in college, it's especially easy to get your hands on a opportunity in a lab, I would say.
Okay, I think these two questions kind of what should go together. How can we come up with original questions rather than conduct a research project that has already been done? And how do you find gaps in research that you can fill?
Mm-hmm. Yeah, I will say, I'll give an example. I'll give a little personal anecdote. Um, Again, time is so relative these days. So recently, in like the past few years, I was involved with a lab that was working on investigating the effects of a drug called rapamycin on tissues, basically. It's a longevity compound, so it's been known to extend lifespan in certain smaller organisms like yeast and flies, mice. So they're looking at how they can translate into maybe kind of like this, not a miracle, but some sort of aging related compound that can help older adults, older human adults, basically. And I was looking through papers and I was looking through my mentors, previous work, and I realized that this drug's effects in lots of different tissues had been investigated, but there was no real solid investigation of how it was affecting brain tissue in mice. There was skeletal muscle tissue that was covered, cardiac muscle tissue, adipose/fat tissue that was covered as well, but no brain tissue. At least I went to Google, PubMed, Google Scholar, all these different research repositories, was looking through, and it's pretty minimal work. So it just kind of sparked because one, I was looking at this drug, and two, I'm a brain nerd, brain enthusiast. So I was like, I wonder what this is like on the brain. And turns out there was a gap there. So I stumbled across it, but I was curious about it. So ended up proposing it, ended up working on it. That's sort of how my project went. Now, of course, it's not always possible to stumble across things. So I will say that oftentimes it's sort of two ways from what I've seen. It's sort of you have an existing experiment, but it's always going to have some limitations because the scope always has to be minimal for a research project. You can't start out with this big because can you imagine summarizing that into like a 10-page paper? No. Funding wise too, that's not going to work out. You need to narrow your scope. Scientists like to solve smaller steps of the problem to piece together the larger picture, basically. So let's say, there has been this little chunk that's been done, but there were some limitations. So they couldn't expand into looking at this particular molecule or this particular pathway in a disease, right? So maybe think about, okay, this drug had been investigated here, right? But not here. This imaging technique had been used to investigate this particular aspect of the brain and this disease. But what if secretly this other XYZ part of the brain was actually implicated in a movement disorder, even if it was related to thinking? Those kind of questions. Take an existing methodology and shift it to another part of an anatomical structure, another disorder, another disease. And think about like if that's feasible. Sometimes a lot of mystery things have come out of chance questions like that. Um, let's see. For instance, the hippocampus, which any neuroscience kids out there will probably know is implicated with memory, is not only implicated with memory, there are so many other functions that it is tied into. However, it was probably not discovered that the hippocampus was doing so many other things unless it was investigated upon from different perspectives. So it is difficult to find those kind of gaps. But I would say that your mentor probably will have some questions in the back of their mind related to their current research, but they can help you, use that kind of an inspiration to formulate your own question. Or it is difficult, to go like straight off the bat, right in with a question of your own. So sometimes what other people do also is they join as research assistants. So they're mainly contributing to helping the mentor, their work, working on their question, assisting them in any way that's possible. And then as time goes, kind of like a sub shoot off of that project. Um, as in like, okay, we're investigating this bigger picture, but we kind of came across some interesting results in this line. So I'm going to see if I can go do some statistical analyses in this route and see if that presents something different. So kind of like a shoot off of a larger plant is another way to go about doing so, I would say. It's no one wakes up with expert questions in mind, definitely, and questions evolve all the time as well. So I think it's fine, if your question is too small or too large to start out with, and that's what mentors can help you refine.
Another question is, how can we stay motivated with researching?
Oh man, it can definitely get tedious, right? You're like, this is really cool at the start, but now I'm just, I'm neck deep in data and analyses and failure at times too, and it can feel like the world is falling to pieces. That is a-okay. It's actually pretty common in academia, and I would say that at the end of the day, think about what kind of skills you're getting out of this experience. Maybe you're working with this complex software that you would have not been able to do so. Maybe you're developing these particular techniques. And also, like a big thing is once you feel that you have understood some particular techniques and you're feeling bored, maybe that can mean that you have to shift the scale of your involvement a little bit. Maybe this is actually not for you, like you thought about. Maybe it just isn't clicking. Some people, like the wet lab, dry lab clinical setting kind of a distinction. Some people don't like wet labs actually, and they may think that they don't dislike the research, but it's more like they dislike the formatting, the methodology of the research. So something to judge. Judging is kind of with more exposure, it becomes more easy to find if you fit in a place or not. So fit can affect your motivation in a lab. Um, your mentor can affect your motivation in the lab. If your styles of mentor-mentee relation just doesn't match, sometimes it does not, and it's not, bad on you or bad on them, right? Sometimes it just isn't compatible. That can also affect your perception a little bit. So finding, mentors that you jam well with can be a big factor as well. Um, and I would say overall, think about this a big cliche, but think about how research really plays out in the big picture by getting more experience in the behind the scenes of what exactly big scientific findings are, you can get more involved in science outreach, like we previously touched upon a little bit. And it can definitely give you a strong understanding of the kind of things that we learn about in science classes. They all came from some sort of research. So understanding kind of the behind the scenes of your textbooks pages and the information behind that basically, um, it's a perspective that really is, I think, once in a lifetime kind of a thing. I think every person should be involved in research, even if it's a short 6 month stint or multiple years. um, yeah, I would say, there are a lot of factors to try to figure out. At the end of the day, some people find out their just research is not for them, and you learn from that. So if you try to troubleshoot as much as possible why you're demotivated, but it doesn't work out at the end of the day, maybe let it maybe time to let it go. Cue the song, but
Yeah, I think we're out of time for today. But if you have any more questions, you can email us and we can pass them on. Or I think you can directly contact Chinmay through any of the things she linked on her presentation. So thank you so much for hosting this, and have a good day, everyone.
Yeah, thank you. Thanks for having me. Thanks for joining, guys.
All right, bye.
Bye bye.